Tarafder from University of Amsterdam, and he'll talk about algebra-valued models of set theory. Please.
So, one little clarification. I'm a PhD student in the University of Calcutta, but I did the coursework for.
Turn on the mic.
Turn on the mic, maybe there's a button with you. On the top.
This one?
Yeah.
Hello. Yeah. I did my coursework of PhD from the University of Amsterdam. So my today's talk is on so here I have written S here and also theories. So generally what we see that we have some set theories which are which are little bit different from ZF, but the basic logic for them are the classical logic. But here my main attention in my work is to work on some set theories whose basic logic is not the classical logic but some non-classical one, like the intuitionistic logic. We know that IZF, maybe the basic logic can be the intuitionistic one, maybe the basic logic can be some paraconsistent logic or something. So and for making the models of those kind of set theories, one way to go to or to reach them is the algebra valued models of set theory. And for doing that, for talking on that, I want to recapitulate for briefly the Boolean valued model for the classical set theory, and then I will come to my point or my work, what I am trying to do here. So what are the Boolean valued models? So let capital B be a complete Boolean algebra, and then I want to make some class like that. How? Suppose alpha is an ordinal number, then I am making this thing as this set will contain all those functions f such that whose range is a subset of the Boolean algebra I have taken, and for any ordinal which is less than alpha, no, not for any, there exists an ordinal which is less than alpha such that domain of f is a subset of B. Okay, and then what I will do, our VB will be like all those things x such that there exists some ordinal alpha where x belongs to some. So this is our VB. Now suppose I am making a language LB on that Boolean algebra such a way that we can make the statements about the elements of VB. Suppose we have made it like that, and how we can make it? We just add some constant name for each elements of this VB in our previous language which we took for the set theory, and after that we are in a position that we can talk about the elements of VB. And now what we actually want to do is that, suppose if I take some statement from this language, then I want to associate this statement with some Boolean value of the Boolean algebra which I have taken. So how I can do that? For doing that, I have to do it for the atomic formulas, and then I have to go. So for the atomic formula, suppose x and y are two formulas of this, or x and y are two elements of VB, sorry, then what is x belongs to y? X belongs to y. So we want this thing as an element of Boolean algebra, and we will write by this that this sentence will be associated with the Boolean value which will be written as this. So that thing will be associated with a Boolean value which will be equal to like and you see here is again one thing. So this is a recursive definition. It will be like this thing. And after defining this atomic 2, so we just say that for any two sentences sigma and tau from this language, this thing will be simply this. This is the complement of this Boolean value, and so after doing that, what we can show, suppose I say that sigma, if suppose I am taking a sentence sigma from LB, and I will say sigma is true in VB, and will write like this if and only so till now I am just recapitulating all the things, and we can show that any axiom of ZF will take the value 1 in this setup, and by this way we can say that VB is a model of ZFC. Now what about if I change this Boolean algebra by a heating algebra, by a complete heating algebra? Suppose if I change our Boolean algebra by a complete heating algebra, suppose H is a complete heating algebra, then I can show that in the same way if I construct VH, then VH is a model of IZF. Now look at these two things. Here it is present, but here it is not present. See. So what about the action of choice in VH? Okay. Let's try to see that. Okay. Action of choice in VH. We know that axiom of choice implies law of excluded middle. I will write it by LEM. 2. Also, it is well known that law of excluded middle holds in VH if and only if H is a Boolean algebra. Here, that means action of choice will hold in VH if and only if H is a Boolean algebra. Why I am writing if and only? One side is coming from this and the another side is coming from that. Okay. So what is happening here? If we just look the proofs clearly, you see, we know that if H is a Hating algebra which is not a Boolean algebra, then VH is not a model of the action of choice. Okay, but now if I add the property, suppose I am writing the property like that, A or A star is equal to 1 for all A belonging to H. Now if I add, suppose I say like dollar, suppose if I add this property dollar with H and call it some H dash, then what we can say? We can say that H dash, sorry, VH dash will be a model of action of choice. Why? Because we know that H plus that thing will make this new algebra a Boolean algebra. Okay, so see, there is a connection between some axiom of the set theory and some property of the algebra here. So the very next question is, what are the connection between the other axioms of the set theory ZF and the properties of the algebra which we are taking here? Suppose I have taken here B or H or something. So my work here is to fix some algebra A. Such a way that A will satisfy some basic properties of this operation. I should not say basic, but I should say that some properties which we expect from an algebra. Suppose, for some example, suppose 1 is the top element, 0 is the bottom element, or suppose like that, if x less than equal to y, if and only if x and y is equal to x. Suppose like that. Suppose my work is to fix some algebra which has some properties which we expect from a basic algebra, and after that, suppose if I am done with this work, suppose I am giving the name of this algebra like basic algebra. Let A is a basic algebra. Then I will construct this thing by the same way here I have explained, and then I will find that which axioms of ZF are taking the value 1 here, or which axiom of ZF is true here in VA and which axioms are not true. That means which axioms are not taking the value 1, or maybe the axioms will not take the value from the designated set. So suppose axiom x of ZF is not true in VA, then my work will be to find which property which is not present in our basic algebra. If I include that property with our A, then this axiom will be true in VA. Okay? And suppose that property is written by P like that. And then the next question will be the A plus P, the basic algebra, our basic algebra A with this property, whether this one is some well-known algebra to us. Okay. Now, if I try to see that what could be the difficulties of this work, one of the difficulties which I can remember now that it goes like that. Which board I should use? This one. You see here, what I have said already, I have said that I have taken only the basic algebra A, but when I am making VA, like VH, suppose, when I am making VH, at that time, what we had the intuitionistic logic as a basic logic of our work. But here, I don't know what is going to be the basic logic for VA. Now, some standard proof where suppose for the axiom X of ZF, when I am proving this thing, suppose in the heating algebra is 1. In the standard proofs, what we have used, that we have used some properties of the heating logic, which has been already taken as a basic logic of our VH. But here I have only A. I don't know what is going to be the basic logic for that VA. So I cannot do that kind of, or I cannot follow that kind of proofs, or I don't know that how I can just get relief by those kind of proofs. So one of the problems of my talk is like that. And now at last, what I will try to say that after doing this kind of works, what I want to do is I want to fix some algebra, suppose K, which will be a basic algebra, okay, at first, and then I will make that Vk, but that K, I will fix this K such a way that K will be the algebra of some paraconsistent logic. And if I can do that, then this thing Vk will be a model of some paraconsistent set theory. And my ultimate goal is to find some model of paraconsistent set theory by this way. Okay? Thank you very much.
Questions?
I assume your models depend on the set theory in which you are constructing this V or B.
Yeah.
Have you investigated this?
So till now, what I have thought that I will take the standard model V for this, and I will make that VA inside of that. Are you satisfied or something? You want to?
I'm just wondering because you can have.
Yeah. So what about the VH? Is not VH lie on V? I'm not sure, but maybe Peter Axel or Bob Lubarsky can.
Well, I've seen instances where sometimes you might you have to do something in particular, so you might need a generic. So you might just start with V, and then you're forced to get a generic extension V of G, and then you can build your model in V of G. It's more useful if you want to take some sort of inner model, like you could have Sourav's VH there, but you may want to take an inner model where you can use the generic you have over your ground model to good advantage. So this is the kind of thing that can happen. I mean, it would be interesting if you may think, well, maybe you have some large cardinal in the ground model or something like that. I haven't seen anything like that because usually, like if you're doing constructive set theory, you're not so interested in large cardinals. Those things haven't really.
I think you're saying that to the wrong person.
We haven't figured out what to do with large cardinals constructively yet. So, I mean, that would be an interesting way to go to see, if you had some, super duper humongous, whatever cardinal, and to say, well, if you were to do this kind of construction, what constructive property does that lead to in this, Boolean value or hiding valued model? I mean, that might be an interesting way to go. But so far, we haven't used any strong properties of the ground model, just perhaps a generic or two. Since I kind of have the floor anyway,
Please.
you were trying to model some sort of some paraconsistent set theory. Well, I don't know much about paraconsistent logic at all, but I do know that there is a school that studied it. I would just assume that one of the things they've done is to try to come up with some sort of algebra of truth values to capture what they're doing. So I don't know what that would be called. Let's say a paraconsistent algebra, I suppose. So have you looked at what your construction does if K is a paraconsistent algebra?
I don't know that whether I have, because I don't know that which algebra I will take at last for making that paraconsistent set theory.
The paraconsistent algebra.
Yeah, so maybe I should look for that sometime, or maybe
That was my question, whether you had done that.
No, I did not do that because I am stuck with the previous stuffs what I have explained already, and then if I'm done with that, then I will go to that.
You're stuck on this?
No.
You explained it to us. What are you stuck on?
No, but what I have said that I want to first fix this kind of algebra, which I have not fixed yet, which are the basic algebras. I have some properties or something, but I don't know that whether that will be complete or something. And then I have to do that. So I am already stuck with, and I have some basic algebra, and I have proved that some axiom of ZF is 1 there, but I'm stuck with some axioms of ZF.
Oh, you mean you put some axioms on A, and you'd like to show that VA is a model of ZF, some version of ZF.
Yeah.
You're not really finished with that.
Yeah, okay. Yeah, I did not finish with that. Yeah.
Well, I would say why not do a parallel track and let A be a particular paraconsistent algebra, one you might be able to understand, and then look at V of that particular algebra. And you may not get a proof that the ZF or whatever, the PZF, paraconsistent ZF, that holds in general, but maybe for that particular paraconsistent.
Yeah, so for that, I have done little bit what you are saying, that because I have taken clean algebra for suppose. So sometimes I have taken clean algebra to see that what is going on, what on the same track what you are referring. So yes, sometimes it is helping me, but I am not sure that whether the clean algebra will ultimately lead us to a paraconsistent logic or paraconsistent model of set theory.
I think we should take the rest of the discussion offline. Let's thank the speaker again.